Hi, it's Mr. Woodbury, and in this video, we're going to go over one proportion test, including the alternative test using the binomial calculator. How do we know this is a hypothesis test? We're given a level of significance, and we're asked to test a claim about a population parameter. How do we know it's for a proportion? Well, the claim is comparing a population to a single percentage, 80%, and we have a sample of 31 out of 35, this many out of that many. Finally, the data here would be categorical. We would find out whether a non-smoker has been exposed to this chemical or not. The answer would be yes or no. Categories, proportions. The first step in a hypothesis test for a proportion, the null hypothesis, is P is equal to a value. That value is the percentage we're comparing the population proportion to. Here, that is 0.80. The alternate hypothesis will also compare P to 0.80, but we're looking for a sign that tells us how we expect the proportion to relate to 0.80. And here it says more than 80%, P is greater than 0.80. We look for indications that it's higher or lower, and if we don't see that, the default is back to not equal to. Second step, level of significance alpha. Here that's listed as 0.05. That's the boundary line for the type of evidence we'll consider to be strong evidence against the null hypothesis. Step 3, the test we're performing, it looks like a one proportion test. Now that may change because the condition may not be satisfied. There's one condition where we have to multiply the sample size by 20 to make sure the population's larger than that. In other words, that the sample size isn't more than 5% of the population size. But the one you really want to check is this one. N times P times 1 minus P has to be greater than or equal to 10. If it's not, then the distribution, the sampling distribution, does not follow the bell curve, and that means we can't use the normal distribution. N in this problem is the sample size. There were 35 non-smokers. P is the value from the null hypothesis, 0.80. 1 minus P, 1 minus 0.80 is 0.20. And when we multiply that out, we get 5.6. Since that is not greater than or equal to 10, we can't do it as a standard one proportion test. We'll have to use the binomial calculator. To do that, there's a couple of things that we need to know heading in. First, in the calculator, we need to know what to use for N. N is the sample size, that's 35. Next, we need to know a value of P. That comes straight from the null hypothesis, 0.80. And we need to have a sign and value for X. Now, the sign comes from the alternate hypothesis, except instead of greater than, we're going to use greater than or equal to, because the p-value we're calculating is the chance of finding a sample that is this extreme or more extreme. This extreme is the equal to part. And it's going to be more extreme or as extreme as our sample result, which was 31. Okay, in a moment, we're going to switch over to the StatCrunch screen, and we're going to calculate a p-value. From there, we're going to make a decision about the null hypothesis, whether we reject it or fail to reject it. And then we're going to say that there either is or is not sufficient evidence to support what H1 says. And here, that more than 80% of non-smokers are exposed to secondhand smoke. If we get a low p-value, that's strong evidence. What that means is that it's really unlikely to get a sample like we saw if the null hypothesis was true. So we're going to take that to be strong evidence that the null hypothesis is not true, and therefore we have enough evidence to support the alternate statement that it's higher than 80%. But if the p-value is not small, 0.05 or bigger, then we can't say that the null hypothesis is false, and that means we can't say that we believe the alternate is true. Let's go to StatCrunch and try this on the calculator. Stat calculator's binomial. N was 35, P was 0.80, and we're looking for greater than or equal to 31. Compute, and our p-value is there to 4 places, that's 0.1435. I know in my math lab, a lot of the times you're only asked for 3 places, you would write 0.143. Both are okay with me. So again, the p-value 0.1435, that is not smaller than 0.05. That means that we failed to reject HO, and that means there is not sufficient evidence to support that more than 80% of non-smokers are exposed to secondhand smoke. Let's try another one. A sample of 607 Americans reveals that 137 of them smoke cigarettes. Use this sample information to test the claim that more than 20% of all Americans smoke at the 0.05 level of significance. Again, we've got a level of significance. We're comparing a population proportion to a certain percentage. That's a one proportion test. Also, our sample, 137 out of 607, this many out of that many. Finally, if you were to gather this data, you would ask an American if they smoke cigarettes. The answers are yes or no. Categories, proportions. The null hypothesis here is that P is equal to 0.20. H1 is that P is greater than 0.20, again, because it says more than 20%. The level of significance is given in the problem as 0.05. This looks to be a one proportion test, but we do have to check the conditions. That is N times P times 1 minus P has to be greater than or equal to 10. 607 times 0.20 times 0.80. I'm gonna have to bust out the calculator on this one. 607 times 0.2 times 0.8 is 97.12. That is more than 10, so this condition is good, and we can do this as a standard one proportion test. When we get to StatCrunch, we're going to compute a test statistic, which is Z, and a p-value. And then we'll come back and say something about HO and the conclusion about H1. This test is under stat, proportions, one sample with summary. The number of successes was 137. Observations, 607. HO, P is equal to 0.2. HA or RH1, P is greater than 0.2. Compute. And we get a Z statistic of 1.58 with a p-value of 0.0567. Which is slightly greater than the level of significance. So again, in this example, fail to reject HO. And that means there is not sufficient evidence to support that. And what does H1 say? Here it says that more than 20% of all Americans smoke. Now, one last thing that I want to say about this conclusion is that if H1 is what we call a one-tailed test, greater than or less than, typically the wording in the problem is acceptable to use in the conclusion. However, if H1 is, say, two-tailed, not equal to, that means that your conclusion has to be about being different So for example, in this problem, it may have said that test the claim that 20% smoke, that the percentage who smoke is 20%. H1 is going to be that the percentage who smoke is not 20% or different than 20%. And when you get down here to the conclusion, that's where you need to write that. Okay, we'll continue on the series next with hypothesis tests for a population mean.